Hello everyone, my name is Noman Saeed from the Computer Vision Department at Mohammed bin Zayed University of Artificial Intelligence. I am presenting our work accepted at WACWI 2026 DuPLUS, a dual prompt vision language framework for universal medical image segmentation and prognosis. Let me start with the motivation. Deep learning models for medical imaging today are overwhelmingly task specific. You train one model for liver segmentation in CT, another for cardiac structures in MRI, and so on. This doesn't scale to real clinical environments. Existing attempts at universal models like DNet with one heart encoding or the clip driven approach rely on simplistic conditions that fails to capture the rich semantic structure of medical language. And critically, none of these frameworks extends beyond segmentation to prognosis, predicting patient outcomes, which is becoming essential in clinical AI. DuPLUS addresses all three gaps. We introduce a novel dual prompt mechanism with hierarchical text control. We achieve state of the art results on 8 out of 10 datasets spanning TCT, MRI, and PET with over 30 anatomical structures. And we demonstrate seamlessly extensibility to prognosis prediction, achieving a concordance index of 0.69 on the Hector head and neck cancer dataset. As you can see in the dataset overview, we evaluated DuPLUS on 10 diverse benchmarks covering 5 CT datasets, 4 MRI datasets, and 1 PET dataset. These range from small benchmarks like PCV with 30 scans to AutoPET with over 1,000. Together, they cover abdominal organs, thoracic structures, brain tissues, cardiac chambers, kidney and liver tumors, and whole body PET lesions, providing a rigorous test bed for generalizability. Now, let me walk you through our approach. The core innovation is the dual prompt mechanism. We use two text prompts that serve distinct roles. The first prompt, T1, is the context prompt. It describes the imaging modality and anatomical region, for example, a CT scan of abdomen. This prompt is encoded by a frozen clipMD text encoder, which is pre-trained on biomedical corpora and used to generate film parameters, scale, and shift values that modulate every layer of the encoder and decoder. This allows the model to adopt its feature representations based on whether it's processing a CT, MRI, or PET and which body region is being examined. The second prompt, T2, is the target prompt. It specifies the exact structure to segment. For example, a CT scan of the liver. The embedding is combined with the deepest image features to parameterize the prediction head. Looking at the architectural diagram, you can see the unit backbone with modality specific input blocks on the left, film layers at every down and up block, and the prediction head on the right. For prognosis, we attach a separate prediction module and use LoRa to fine-tune the text encoder with structured EHR data, patient age, gender, clinical history without retraining the whole model. Moving to our experimental results, all models were trained under identical conditions, same ResUnit backbone, same pre-processing, 200 epochs to ensure a completely fair comparison. As table 1 shows, DuPLUS achieves the best dice score on 8 out of 10 datasets. Our strongest results include 97.1% on DLBS brain segmentation, 90.7% on MOS CT with 15 organ classes, and 68.6% on the challenging LITS liver tumor task. The only two datasets where Hermes performs better are KIDS tumor and AutoPET, where we believe its implicit learned priors may be more effective for subtle tumor boundaries. The qualitative results really showcase the power of our approach. In the top two rows, you can see that for the exact same CT slice, simply changing the T2 prompt from spleen to liver to pancreas deterministically switches which organ gets segmented. In the bottom rows, by only changing T1 from computed tomography to magnetic resonance, the model segments the same abdominal organs across both CT and MR images without any retraining or modality specific weights. To demonstrate extensibility, we fine-tuned DuPLUS on the Hector dataset, head and neck regions, completely unseen during training. For tumor segmentation, we achieved 0.674 dice outperforming Swin unit, R unit, and 3D URES unit. For prognosis, we reach a concordance index of 0.69, surpassing established survival analysis baseline, including Cox, pH, and deep hit. Our ablation study provides strong evidence for dual prompt design. When we mismatch T1 giving the model incorrect modality, our region information performance drops catastrophically by 54 to 87 dice points. But mismatching the modality in T2 causes only a minor drop of about 2 points. This confirms the hierarchical design. T1 is responsible for the broad imaging context, T2 handles precise target selection. The organ control experiment is definitive. The model achieves 95 to 97% on the prompted organ while producing exactly 0% on unprompted organs visible in the same image. To summarize, DuPLUS establishes a new state of the art for universal medical image segmentation, working across 3 imaging modalities, 10 datasets, and over 30 anatomical structures. Its dual prompt mechanism enables steerable text control segmentation where clinicians can query specific organs through natural language, and the architecture extends seamlessly to prognosis prediction through parameter efficient LoRa fine tuning. Looking ahead, we plan to explore free-form clinical text inputs, extend to classification tasks, and work toward integration into end-to-end clinical decision support systems. Thank you for watching. Please feel free to reach out